We are doing 5, 6, and we're splitting this up. So 5, 6 is going to cover the parallel lines, and then 5, 6A is going to cover the parallel lines. 5, 6B is going to talk about perpendicular lines, but they're very similar lessons. You just do one slightly different thing. Can anyone tell me what parallel lines are? That, Ryan. They never touch, okay? So parallel lines are lines in the same plane. This is parallel lines. Lines in the same plane that never intersect. Okay, that is parallel lines. So the way we tell if two lines are parallel is if they have the same slope but a different y-intercept. Okay, so two parallel lines have these two things. One, they have the same slope, and two, they have different y-intercepts. Okay, now here's what I want you to think about. Why does it matter that two parallel lines, so this or this or this, why do they have to have different y-intercepts? Why can't they just have the same slope? Can you picture what that might look like? Two lines. Because they're what?
Well, they're like on top of each other if they have the same.
They're the exact same line, right? If they have the same slope and the same y-intercept, they are the same line, therefore it's not two separate lines. So the reason you have to have a different y-intercept is to make sure that it is a different line, not the exact same line, okay? Because two lines that are identical can't be parallel, okay? Ryan, will you put that away, please? So one example of parallel lines, I'm going to pull up a graph here real quick. Oh, recent. That's beautiful. That's new. All right, so say we have this coordinate plane. Oh, that didn't go well. And I give you a y-intercept here. And I give you, so that would be this line. Okay, and I give you a y-intercept here. And you get this line. Okay, notice different y-intercepts. This one has a y-intercept of 4. This one has a y-intercept of 1. Okay, but their slope is the same. If I start here, you go up 2 over 1. Here you go up 2 over 1. So they both have a slope of 2 over 1, but different y-intercepts. Okay, so that would be parallel lines. Those are parallel, never going to touch. Okay, what you're going to have to do with this is,
Up 3?
it was up 2 over 1. It doesn't matter if you follow the same, so I just wanted you to see what parallel lines look like, so you don't have to draw it identically necessarily. All right, so here's our first example. It says a line passes through the point 12, 5 and is parallel to y equals 2/3 x minus 1. They're going to say write an equation in slope-intercept form. Okay. So you have to think about what is being said here. They're giving you a point, okay, and they're giving you a line. So that's the 2 in blue. You have a point and a line, and they want a line parallel to this line, but it has to go through 12, 5. Okay. So what you got to figure out is, first of all, if the slope is going to be, or if the lines are going to be parallel, what is the new slope going to be? The slope of our second line, if it has to be parallel to this line. Which is what? 2/3, right? So we know we have a slope of 2/3. We just need to figure out in y equals mx plus b form, what is b? What is our y-intercept going to be? Okay, so we need to find our y-intercept, and we have an x and a y to be able to do that, right? The 12,5 is our x and our y. So what we're going to do is we're going to take the x, the y, and the m, and we're going to plug it into slope-intercept so we can find our b. Okay, so let's do that. Y was what value? 5. 5 is our y. M was here, our 2/3. What's x? The 12 up here. Okay, that's our x value. And then plus b. Okay, so we're plugging it into slope-intercept and figuring out what b is. So now from here, it's just algebra. Solve it. Simplify. So 2/3 times 12. Anyone know what 2/3 of 12 is?
Oh, it's not just 3 times 12?
No, it's technically 2 times 12 and then divide by 3 would be the way you could do it. Or you can just do 2 divided by 3 times 12. That would work too.
8.
It is 8, right? 2/3 of 12 would be 8. So you have 5 equals 8 plus b. And then you would just solve by subtracting 8. So you get -3 for b. What does b represent? Your y-intercept, right? So we just found our y-intercept. It said put it into slope-intercept form. So you have a slope, you have a y-intercept, you just plug it in, okay? So here's our slope. Let's do a different color here so you can see. Here's our slope. Here's our y-intercept. So that's going to be y equals m, 2/3, times x, plus a -3, which is easier written as just -3. Okay, so that would be your final answer, slope-intercept form. Y equals 2/3 x minus 3. Does that make sense? So they give you an x and a y up here, and they give you the slope. You're just plugging all of that into slope-intercept form to find the missing piece. Yeah, Ryan. You sure?
Yeah.
I would like to help.
If slope-intercept form is y equals mx plus b, then in that equation y equals 2/3 x minus 1, what is the 1 supposed to be?
This is the y-intercept of the line they gave us. So right now they're saying we want a new line that's parallel to that line.
Yeah.
So if it's going to be parallel to that line, you can't use that -1 or it would be the exact same line,
Okay, so
right? Okay. So they give you a line with a y-intercept. You need to find the y-intercept of the line that goes through 12,5 instead. It's a good question. Thank you for asking. Okay. There's another way that you could do this if you wanted. Do you want me to show you another way, or do you want me to stick with one way and call it good? Okay, because the other way is this. You're given a point, and you know the slope, right? So you could put it into point slope form and turn it into slope-intercept, okay? So I'll show you that too. If you don't want to do it that way, you don't have to do it that way. It's just another way of doing it if you don't like this way, okay? I actually like the second way better, personally, but that is up to you. So here's a second example. So they're going to say, we want to do a line that goes through -3, -1, and is parallel. Whenever I do the two lines, for those of you that didn't have me first semester, I just mean parallel by that, okay? So this represents parallel. So it goes through -3, -1, and is parallel to y equals 2x plus 3. Okay, so essentially it's the same problem. We want to be parallel to this line. We want to go through this point. So you could call this x and y, and then the 2 would be your m, and you could plug it into y equals mx plus b, solve for the b, and then plug it back into the equation. Okay, could do that way. The other way you can do it is if you know point slope form, y minus y1 equals m times x minus x1, we have all the information to plug into that right now. So you don't have to do as much solving, I guess you would say. Okay, so if you're going to do it this way, here is your x1 and your y1, and here's your m. Okay, so we're going to plug those into this formula. Y minus, what's your y1?
3.
Not -3. Look here.
Oh.
-1, right? So you're going y minus a -1, which is really y plus 1. Okay, so y plus 1, what's m? 2. We want to be parallel to this line, so it has to have the same slope. And then x minus, what's your x1? -3. X minus a -3 would be x plus 3. Okay, and now all you have to do is turn that into slope-intercept form. So you would distribute this. Y plus 1 equals 2x plus 6. Okay, and what do I do to get it into slope-intercept now?
Subtract the 6 or
The 1, right? Because we want y equals something. So take away the 1, and you get y equals 2x plus 5. Okay, so here's the thing. I showed you 2 examples, but they did the exact same thing. So you don't need to know how to do both. You pick the one that is easier to you, and you do it that way. Okay? Just out of curiosity, who thinks they'll do the first way? And who thinks they'll do the second way? And the rest of you are undecided at this point.
I might do both just to check it.
You could do both. Okay? Okay, let's do one more the first way then, since the majority of you thought you would do it that way. And then we'll be done. That is it for today. Yeah. All right, so let's say this one is going to go through the point 2, -1. And we want to be parallel to y equals, I don't know if this is going to work out to nice numbers, but we'll get the point. 3x plus 6. Yeah, we'll be okay. Okay, so if this is our setup, to go through this point parallel to that line, where do we start? Anyone remember? Ryan. Right, so we have an x value, an x value and a y value, right? We're just going to plop them into slope-intercept form with, what's our slope? 3. Okay, so if we're taking slope-intercept and putting numbers in, what's going to go in place of the y?
-1.
Right, -1. What's going to take the place of the m? 3. What takes the place of x? 2. Plus, and then b we don't know, that's what we're solving for, right? So you have -1 equals 6 plus b. So we're going to take away the 6, and you get -7 for your b. Then what do you do? Now you put it into slope-intercept in that standard form of slope-intercept. So you, not 6x. What's our slope? 3, right? So you're going to do y equals, God bless you, 3x. And then instead of plus 6, it's just going to be -7. So here's the beautiful thing. If it's going to be parallel to this, the only thing that's going to change in that equation is this number, right? It's still going to look like this. So your answer should be y equals 3x, fill in the blank, okay? We're just plugging everything in so that we can fill in the blank. So that's how we come up with that -7. Does that make sense? Do you want one more? You feel good? Yeah? Okay. I'm going to give you